Hi, this is Mr. Patch. We're going to look at measuring density today, or calculating density. Density, as you may know, is mass per unit volume. That means you have to measure the mass, calculate the volume, and then do a calculation, mass divided by volume, to get the density. Density is one of those derived units. It's a unit that has to be derived or calculated in order to get. So what I have is I've got a group of 5 blocks. They're all regularly shaped blocks. And we're going to figure out the mass of those blocks and also the length and the width and the height of those blocks. Later on, then we'll calculate the density from that. Hi, this is Mr. Patch again. We are going to look at the masses on the balance of our 5 blocks. So we've got block E, block U, block M, block G, and block C. So they were all cut from the same piece of wood. They're all made out of the same material, American walnut. And I'm just going to put them on the balance one by one. I'm not going to tell you what the mass is, but you should read the balance as I put them on, mark down the data. Before we do this, we always zero out the balance. This balance looks pretty steady. On a regular table, you don't even want to be leaning on the table or breathing on the balance or anything. All those things can throw off your measurement. So we're going to start. Clear it out. Here's block E. Clear it out. Here's block M. Gonna clear it out. Here's block U. Clearing it out. Here's block C. Going to clear it out. Here's block G. Okay, I'm turning off the balance. If you're in the chemistry class, I'm going to add some additional items here for you. Once again, we let the balance run through its regular start-on procedure. We make sure it's steady. And so what I have here is I've got a cylinder of aluminum. Zeroing it out. Sometimes it takes these a while to sort of to stabilize. That looks like it's the most stable reading. Zero it out. I've got a golf ball. Top flight, if that makes any difference. Next, I've got, zero it out, cylinder of copper. Next, I've got an irregular shape. It's lead. And that's it. This is block E. This is the length of block E. Next, I'm going to zoom out and we'll go ahead and we'll get the width of it. So, I'm lining it up here. Here is the width of block E. As you can tell, the camera's not completely cooperating. There we go. All right. And next, what we want to do is we want to get the height of block E. And here's the height. Once again, the camera's not completely cooperating. There we go. Just take your best shot at it. Next, we're going to go with block M. Once again, we're going to start off with the length first. Lining it up with the 0 on one side. That's what we've got for the length. Block M, the length. Let's look at the width. Lining it up. And here we go with the width of block M. Take your best shot. It's a little hard to tell, but just take your best shot. Remember, you're measuring at least to the 10th place, at least to those lines. Next thing we're going to do is we're going to go to the height of block M. This one doesn't like to zoom in too far, does it? And I think that's about right. Height of block M. Next is block U. That's the length. Here's the width of block U. The height of block U. The next one is block C. We're going to start off with the length of block C. Here's the width of block C. Here's the height of block C. Next, let's go to block G. Here's the length of block G. Here's the width of block G. Let me see, I think I was calling this, we'll call this one the width of block G, just for consistency. Once again, just take your best shot. I can't zoom in to make it the perfect shot here. And we'll look at the height of block G over here. That might be over a tiny bit. There we go. All right, height of block G. There we go. So next we're going to go with the aluminum cylinder. Just take your best shot right there. That's the height of the aluminum cylinder. And the other thing we want to measure for the aluminum cylinder is going to be the diameter. At its widest point. So I'm going to try to do it right across that circle and hold it there for you. And it's not very clear, is it? Let's see what we can do here. This is supposed to be, that's more like it. So hopefully that helps. That's the diameter of the aluminum cylinder. Let's look at the copper. Here's the copper cylinder. And right about there, that looks pretty good. Let's look at the diameter of the copper cylinder. Once again, I'm going to try to measure it right through the middle of that circle. And you want the diameter, remember. And that one looks like it's doing okay. Hopefully that's working for you. The next one, which is a little bit strange, is going to be this, the golf ball. You're probably thinking that was going to be, I'll probably have to tell you some things on that one. So, we need formula 4/3 pi r cubed, but of course we can't really figure out the radius by cutting it in half. So what I'm going to try to do is I'm going to try to bring this string, this fishing line, around it. Okay. So I'm taking a fishing line around it, and now I'm going to hold that fishing line. I'm trying to get the circumference of it, and then I'm going to hold that fishing line right there at that point against my ruler and see what we get. See if this thing works. It's kind of a funny way to do it. And right there, that's the spot we're looking for. I don't know if you can see that. Right where the edge of my thumb is, that is the circumference of the golf ball. So write that number down. Let's see if we can get in a little bit closer. Maybe we can. There we go. The last thing we're going to measure is this irregular piece of lead. Looks like it's from a fishing weight or something like that. And you need to have the initial and final volume of water in the graduated cylinder. I'm going to shake this a little bit so you can see, sort of get an idea where it is. All right. And remember, you want to read from the bottom of the meniscus, the bottom of the curve, or you can think of it as the middle of the curve. I'm now going to take that graduated cylinder and I'm going to tilt it and slide the piece of lead in it. I'm going to do that to protect the graduated cylinder so I don't drop something heavy in it. So I'm very slowly just sliding the piece of lead down. And what we should see is a change in the water level. And you want to record the new water level on that graduated cylinder. I'm moving it just a little bit so you can sort of see it. Then I'll let it stabilize there. Okay, this is the final volume of the water level containing the lead in the graduated cylinder. So that should give us all the information that we need now to calculate our densities.